Welcome to Lesson 7 of Module 2 on Introduction to Databases and Database Management Systems. I'm going to start with a trivia question that you should be able to answer after this lesson. What company pioneered early advancements in relational database technology? This lesson provides informational background about historical advances in database technology. You have two learning objectives in this lesson. I want you to develop an appreciation about major advances in database technology to the software industry and modern society. As a more concrete objective, you should be able to list major periods of database technology evolution and one advancement in each period. Database management systems have experienced tremendous product evolution over 50 years, resulting in what I think are four generations of products. The first generation supported sequential and random searching of files, but the user was required to write detailed computer programs to access data. The database software industry had little or no standards during this period. The second generation products were the first true database management systems, as they could manage multiple entity types and relationships. However, to obtain access to data, a computer program still had to be written. Second-generation systems are sometimes referred to as navigational because the programmer had to write code to navigate among a network of linked records. There was some progress on standards, although IBM, the major computer company at the time, ignored the standard. Third-generation systems are known as relational DBMSs because the foundation based on mathematical relation and associated operators. Optimization technology was developed so that access using non-procedural language would be efficient. IBM performed pioneering research and development in the 1970s to enable commercialization of relational database technology in the 1980s. Fourth-generation DBMSs are extending the boundaries of database technology to unconventional data, new kinds of distributed processing, and data warehouse processing. Fourth-generation systems can store and manipulate unconventional data types such as images, videos, maps, sounds, animations, and web data. Most DBMSs now feature convenient ways to publish static and dynamic web data using the extensible markup language as a publishing standard. Because these DBMSs view any kind of data as an object to manage, fourth-generation systems are sometimes called object-relational or object-oriented. A current focus for fourth-generation DBMSs involves the challenge of big data. As the name implies, NoSQL, or not only SQL, database technology extends beyond the traditional relational database model and SQL standard. Instead, NoSQL database products use simplified database models, less stringent transaction processing models, and distributed processing to reduce bottlenecks for dealing with big data. The technologies developed in NoSQL database products have been adopted in traditional relational database products, so the distinction between NoSQL and SQL databases has become blurred. Innovation in the database software industry continues with major advancements in recent years. DBMSs have new features to support business intelligence processing for data integration and usage of summary data. The second and third courses in this specialization will cover these advancements. Cloud computing is a recent area of product development for both established DBMS vendors and new vendors. Cloud computing supports on-demand and pay-per-use access by both data and software. Cloud computing usage is web-based without the fixed cost of software ownership. Major DBMS vendors have developed cloud computing models as an alternative to the traditional approach of product licensing and ownership. In addition, a number of new vendors have created DBMS products tailored to the cloud computing model. Part of the promise of cloud computing is support for applications with exploding data growth, known as big data. The growth in data comes from a variety of sources, such as sensors in your smartphones, energy meters in automobiles, interaction of individuals in social media websites, radio frequency identification tags in retail, and digitized media content in medicine, entertainment, and security. Big data needs exceed the limits of commercial database software to capture, store, process, and analyze data. NoSQL, more formally known as not only SQL, technology has been developed to deal with some of the challenges of big data. In the enterprise DBMS market, Oracle is the clear market leader with more than 40% overall market share. Oracle has strong competition in some environments from Microsoft SQL Server, IBM DB2, Teradata, SAP Sybase, and open source products. In the desktop DBMS market, Microsoft Access dominates, at least in part because of the dominance of Microsoft Office. Open source DBMS products have begun to challenge the commercial DBMS products at the low end of the enterprise DBMS marketplace. Although source code for open source DBMS products is available without charge, most organizations purchase support contracts, so the open source products are really not free. Still, many organizations have reported lower cost of ownership using open source DBMS products. MySQL, first introduced in 1995, is the leader in the open source DBMS market, but with competition from MongoDB, PostgreSQL, MariaDB. The website dbmengines.com ranks DBMSs by popularity using the number of mentions on websites, frequency of search in Google Trends, job offers in leading websites, and profiles in professional websites. The DB Engines ranking, top 10, in June 2017 was Oracle, MySQL, Microsoft SQL Server, PostgreSQL, MongoDB, NoSQL product, DB2, Microsoft Access, Cassandra, a NoSQL product, Redis, NoSQL, and SQLite. In summary, I want to reiterate the point that I've made in previous lessons. Databases and database technology are vital to modern organizations, supporting both the daily operations and decision-making. Database technology has undergone remarkable evolution over 50 years. Despite dominance of the enterprise DBMS marketplace by Oracle, the industry remains highly competitive with a continued high level of innovation. The second and third courses in this specialization will cover innovations in database technology to support data warehouses and business intelligence processing. In answer to the trivia question in the beginning of this lesson, IBM dominated early development of relational database technology in the 1970s, just as IBM dominated the entire computing industry at the time. However, despite lots of research and development, IBM was not able to dominate the DBMS marketplace over time.